Okay, now you've heard of machine learning, but how about machine teaching? Our next segment brings us through to the world of autonomous systems. Let's take a look.
Hi, welcome to Autonomous Systems in Action. My name is Paul Stubbs. I'm a marketing director for AI and innovation at Microsoft, focusing on autonomous systems. I think about all aspects of making physical systems autonomous, including robotics, drones, manufacturing, and other industrial control systems. I will show you autonomous systems in action using Project Bonsai, our machine teaching platform to create an AI model running on Project Moab, our ball balancing learning robot. Industrial control systems, as we know them today, are built on automation. They rely on understanding how disparate inputs interact to affect expected outputs. And while traditional control systems like a proportional integral derivative controller, or PID, are limited to a series of pre-existing set points, autonomous systems use AI to create strategies and can identify an ideal conditions where those strategies ought to be deployed to help human operators achieve their desired output. Project Bonsai is our platform for autonomous systems using a new approach to AI development called machine teaching. With Project Bonsai, domain experts can leverage their knowledge to teach the machine without experts in data science or deep reinforcement learning, which is a branch of AI in which algorithms learn by trial and error based on a system of rewards. And in ambiguous and challenging reinforcement learning scenarios where algorithms have trouble figuring out which of the millions of possible actions it should take to master tasks in a physical world, machine teaching can dramatically shortcut the time it takes an intelligent agent to find the solution. Project Bonsai is a complete toolchain for building, training, and deploying AI models, also referred to as a brain. So Project Moab is a device for users to learn, explore, and build autonomous systems with Project Bonsai's machine teaching platform. I have a Moab device with me here. This device has 3 arms powered by servo motors. These arms work in tandem to control the angle of the transparent plate to keep the ball balanced. Under the plate is an up-facing camera that can see objects placed on the plate. The Moab device tracks and maps the ball movement into a standard 2D coordinate system. Looking at the front of the device, the x-axis runs from left to right and the y-axis runs from front to back. And the plate at the center location is 0, 0 with a radius of r. The same coordinate system defines the 2 angles of tilt. Pitch is the plate angle about the x-axis and roll is the plate angle about the y-axis. A perfectly level plate would have a pitch and roll of 0, 0. Let's take a look at a quick demo. First, I will log into Project Bonsai's site at preview.bons.ai. In this demo, we want to use the Moab to balance a ball on a plate. Ball on plate is a more complex variation of the classic cart pole problem that engineering schools teach. We will use Project Bonsai to create a trained AI model. The trained AI must learn how to adjust the plate pitch and roll to balance the ball on the plate. Let's create a new Bonsai project using Moab sample template. There are 3 main sections. On the left is the navigation side panel. It shows the brain projects that you have created in any managed simulators you are using. In the center is the Inkling code. This is the machine teaching language that enables you to define the observable state, concept goals, and actions. And on the right is the interactive graphing panel. It is a visual representation of your Inkling code. For this demo, we do not need to make any changes and can start the training. When the training starts, Bonsai launches multiple Moab simulator instances in the cloud. The training progress is reflected in several UI sections. The performance plot displays the average performance of the AI model. In this case, there are 2 goals: to avoid falling off the plate and to drive the ball to the center of the plate. And then there is a 3rd line that shows the average of all the goals. There is also a live visualization of the Moab simulator below the performance plot. So when should we stop training? The goal satisfaction percentage trends up during training. Once the line converges and flattens around 100%, you know that you have reached the peak training performance. In the Moab example, it should take less than an hour. So now we're ready to export the trained brain to use in our Moab device. So here I've already deployed the brain to this Moab device here, and after you deploy your Moab device, you can see it in action. So when I put the ball on the plate, we'll see this. The first thing we need to do is calibrate the system so that the camera can recognize objects based on the current lighting conditions in the room. So I'll choose calibrate on the menu. And we have our calibration device and the ball on the menu already, so I'll just click the joystick. It's ready to calibrate, so I'll click it again to calibrate, and we're calibrated. So now I can remove the calibration device, which is just a small plastic holder. And now let's first start by moving the ball to manual mode. In this case, I can use the controller to manipulate the ball. And it's actually challenging to coordinate this. Let's go ahead and let the AI model do it. So we'll choose brain. Now the AI model is going to control this, and we can see that it's eager, it sees the ball, and it's ready to go. So I can just drop the ball on the plate. I can also move the ball around, and it tries to center. I can also do aggressive things like bounce the ball, and it catches it on the plate. And so here the brain is looking up with the camera and seeing the ball on the plate. You can learn more about Microsoft's Autonomous Systems platform at aka.ms/as. You can learn more about Project Moab at aka.ms/moab, which includes the complete walkthrough you saw in this presentation. And be sure to sign up for Project Bonsai preview at aka.ms/as/get started. Thank you for watching.